So, unser vorletztes Team now von der BTU, Team NetZero.
Okay, hello everyone. I hope you are doing well. My name is Yasser Salem and we are Team NetZero, your optimal energy source and our solution to optimize energy usage in the industry and especially in faculties. So, let's get started. Let's point at the elephant in the room and why we're all here in this event. To be carbon neutral, humanity needs to capture about 20 billion tons of CO2 per year. This is a crazy number, so crazy that you can compare it to a forest of the size of 2 Brazils. We can't plant those and we don't have the time or the patience or the time to do that. So the best way to do it is to focus on conserving energy and optimizing our usage. So right now we have a graph. It's just a point that from the 1900s till now, right now the global CO2 emission is an all-time peak. So we need to do something about it. Also, we can see that per region, regions like China are consuming a lot more CO2. And because China has a lot of factories, so we have to do something especially about that. Okay, let's get to the use case. So imagine a factory. A factory has multiple machines, and each machine works 24/7. Maybe less, maybe more, not more, but probably less. And this machine keeps using energy all the time. So it's not optimized, there's no schedules. Maybe there's less schedules, but it's not adaptive whatsoever. So this is the problem. We have 4 problems that the machines basically are fixed scheduled or manually controlled. So someone goes up to machine and then turns it off or turns it on. And then there's also the unpredictability of renewable energy. We can't know how much renewable energy we have right now or we will have today or in this week. Also, there's specific machine needs, how much this machine specially consumes energy. And there's no real-time optimization, and this is where we will come. We are presenting our solution. Our solution is called NetZero, and basically we're collecting data like machine information, energy sources, and so on, and we're feeding it into 2 models. An AI model, which is an optimizer, and a chatbot, just so it can communicate with the user. So the optimizer goal is to prioritize the consumption of renewable energy over the fossil energy, as well as write a schedule for the day, for the week, or whatever the case may be, for the machines. And the chatbot, of course, is just a way to communicate with the user and maybe recommend it or plot some plots. Okay, so a bit more details. We're using reinforcement learning, and this is just an example of the environment being the factory and the agent being the supervisor for this factory. And the agent takes an action, and then it affects the environment, and then the environment responds with a reward or a penalty. And this is how the AI is trained. So enough about that, and let's get to, so brief, the model are divided into 2 parts, optimizer and chatbot. Now let's get to the demo. Okay, so this is a Hackathon exclusive solution. This wasn't built before. And basically what you do is you first search for the city. So let's say, for example, Cottbus. And then you do fetch data, and then it predicts the sun availability and the wind availability, and the fossil power is manually controlled. And then you have the total available energy, the renewable energy, and the fossil energy. Okay? And now you can also control this fossil power and control each machine manually. So this is like the standard. You control each machine manually, and now you have the 6 machines. Each machine has its demand, how much it requires energy, and if it's on, if it's off, or whatsoever. And this is where our solution comes. The optimized machine usage, and now, for example, because we have B turned off, and now we can optimize each hour if the machine will be on or off. And this way, you can optimize the usage of renewable energy as well as optimize the total usage. Okay, so let's get to it quickly. Let's see the chatbot. which is basically the assistant panel. This chatbot, you can chat to it. Let's plot a line. Let's say, for example, we want to plot a line that shows the energy consumption over time. Okay, and my friend right here is writing right now the prompt. It feeds in, and now it plots the time. It plots the line chart over the hourly demand for each hour. So this is hour 0, this is hour 7, and each hour how much energy is consumed. So let's plot one more thing and say, let's visualize a bar chart for the different energy used, like fossil energy, wind energy, or solar energy. That's the other one. So this is also a solar chart, the solar usage, the wind usage, and the fossil usage. Let's get back to the presentation with Abdelaziz.
Okay, now let's talk money. We took the initiative by contacting some energy source leading companies such as Siemens Energy, BV, and ANBV to take advices from experts and plan future co-work. Then we performed a market research to see what are the market trends currently. And we found that renewable integration incentives are reshaping energy economics, and the global industrial energy efficiency sector is experiencing rapid growth. So after that, we asked ourselves, who can buy our solution? We found that our target market are sustainability-focused corporations and manufacturers and factories, and also small to medium enterprises with raising energy cost. After that, we focused on how can we perform our marketing and sales strategy. We find that we can put it over 3 main pillars, which are pilot partnerships, offer free trials to factories in exchange for testimonials, also industrial trade shows, exhibit at energy and manufacturing expos, and channel sales, partner with energy consultants and industrial automation firms. After that, we put our pricing model by subscription-based software as a service solution, so we can take monthly fee per machine or a plant. Also, we can take one-time setup fee. Then we said that, okay, we have a lot of data, so how can we collect this data, and what are the type of these data? We found that we have energy consumption data, environmental data, operational data, and user interaction. How can we make a benefit from them? We can monetize them by selling them to researcher universities, factories interested in enhancing their energy, and also AI machine learning startups in energy optimization. So as a conclusion, we find that by replacing 10 megawatt hour of fossil energy with renewable energy, you save approximately 10,000 kilograms of CO2, which is equivalent to taking 2 gasoline-powered cars off the road for a 4 year. So you can imagine how our planet will look like if we applied our solution to all the factories in the world. So let's decarbonize the industry. Any questions?
Thank you for the presentation. Well, you already mentioned what you would want to do as the first steps, maybe as a pilot project, but I want you to be more specific. With what company do you see yourself working, for example? Which machines do you see yourself working with as the very first project?
Okay, so a company that we have in mind is Fraunhofer IPK, which is basically just trying to solve a real-world problem in the industry. So if we work with them, they have a full lab with a lot of machines where we can implement our hardware to gather the data, and as well as actually use the machines to turn it off, turn it on, using the API. So I currently work with Fraunhofer, and this can be a good approach because I've been in the lab, and we can start this by just communicating with them, and yeah, that would be our first step.
Thank you very much for your presentation. I have a question regarding the chatbot, what you have implemented.
Okay.
Is it a local chatbot, or do you transfer the data somewhere else?
Okay, so DeepSeek is a free model that we can integrate it to our own laptops.
Good.
So we did that. And we also implemented a RAG solution. So this was our friend right here, our third partner, who was working with us. He implemented a RAG solution. So it collects data from the data set, and it has knowledge, and then it uses it to answer questions. And for the visualization, we just connect it to a function that has undetermined parameters that we can fill depending on the user's query.
Mm-hmm. Okay. And maybe an additional question, so to get the data from, let's say, the real world processes, what kind of requirements of the machine do you need to get the data and also to interact? So because you have to control them, I show in your presentation that you can turn them on off, but you need the interface for that. How do you do that? So how do you get the access to the machine data and to access them turning on off?
Okay, usually in any system there is something called industrial control systems. Yes. There's inside this we have something like HMIs, human machine interfaces. So maybe we can get these data from these APIs, and also there's additional something regarding the security. We can perform something like a honeypot or adding some intrusion detection systems, so that if regarding any security issues in the future.
Is it so open that you get access to this data?
What?
Are they so open, the vendors of the PLCs, for example, to provide you the data? Normally they are very shy to
yeah, I think
you an API.
If they want to integrate our solutions, then we will put this and customize it for them. So maybe they will give us their APIs so that we can work on them.
Very good answer.
Yeah, so that is true. And just to point that out real quick, we did, just to mention, because I did work with a machine before, and we had to contact the company, and we actually got a supervision or a consultancy, basically. It costed 100 euros just to talk to the company and for them to give us access to the machines. So yeah.
Okay, once again, it's time. Thank you for the presentation, and next team will continue.